Hello everyone, this is Manohar Reddy, Department of Cybersecurity, Institute of Aeronautical Engineering. Today I am going to discuss about the concept of definitions and terminology on indexing and hashing. So indexing and hashing. So what is meant by index and what is meant by hash, and how we are going to use the indexing mechanisms, hashing mechanisms to retrieve the data. So here indexing mechanism. So index are nothing but what? Creating a buckets or creating a storage for accessing the data very fastly. So here indexing mechanism is used to speed up your access. So indexing mechanism is used to speed up your access of the data. So for example, if I have different types of data in the tables, if I want to retrieve the data, there is a lot of records are there. But without having the separate mechanisms, you cannot use it to retrieve the records. So at that moment, we can use the concept called indexing concept. So indexing mechanism is used to speed up the access to desired data. For that, an index is created. For that, we need to create an index, so which contains index files. So each and every file contains what? Search keys. Each and every index file contains what? Search keys. So here the search key is nothing but what? It is an attribute to set of attributes used to look up the records in a file. So here the search key is an attribute to look up the records in a file. An index file consists of records. It is also called as what? Index entries. So all the entries are having an index file which contains the records as like the form. So here search key and pointers. So this is the main index having the mechanism. So which contains what? Index contains what? Search key as well as pointer. Those two it is having. So to speed up the accessing of the data, we can use the concept called indexing. So here index entries, all the files are nothing but what? Index entries, and this search key is used to look up the records of the index file. So index files are typically much smaller than the original file. So it is much smaller than original file. So there are two types of indices are there. One is what? Ordered indices, and the second one is what? Hash indices. One is what? Ordered indices, and the second one is what? Hash indices. So ordered indices are nothing but what? Search keys are stored in sorted order. So search keys are stored in sorted order. And hash indices, searching keys are distributed. Search keys are distributed uniformly across buckets using hash function. So they are distributed across the buckets using hash function. So across using hash functions. So two types of indices are there: ordered indices and hash indices. So what matrices they are going to using this indexing mechanism? So reducing the access time. To reduce the access time, we are going to use the index mechanism. Reduce the insertion time also. We are using the indexing mechanism. Reduce the deletion time. Also we are using the indexing mechanism. And reduce the space overhead also. Reduce the space that is taken by the by the database. Also we can use the indexing mechanism. So ordered indices. In an ordered index entries are stored. So ordered index is nothing but what? Index entries are stored sorted order on the search key value. So all the search keys are stored in sorted order. That is nothing but what? Ascending orders. Sorted order lo the search keys are stored. So that is nothing but what? Ordered index or ordered indices. So example, author catalog in library. So who is the first author, who is the second author, everything will be in ordered, sorted order. So primary index. So primary index in a sequentially ordered file, the index whose search key specifies the sequential order of the file. Whose search key specifies the sequential order of the file is called as what? Primary index. Is called as what? Primary index. And it is also called as what? Clustering index. And it is also called as what? Clustering index. So that is nothing but to avoid confusion with the primary key. Avoid confusion with the primary key. The search key of a primary index. The search key of a primary index is usually but not necessarily the primary key. The search key of a primary index is usually but not necessarily the primary key. And the secondary index. So an index whose search key specifies an order different from the sequential order of the file is also called as what? Non-clustering index. So all the sequential file contains what? Search keys are ordered, and all the search keys are not ordered in the sense that is not sequential order. So that is nothing but what? Secondary index. And also it is called as what? Non-clustering index. And it is also called as what? Non-clustering index. And index is sequential file. So the ordered sequential file with primary index is called as what? Index sequential file. So ordered sequential file with a primary index called what? Index sequential file. And primary and secondary indices. So primary and secondary indices. So indices or indexes. We can call it as what? Indices or indexes. Indexes offer substantial benefits when searching for records. So substantial benefits for when searching for records. But updating indices imposes overhead on database modification. When a file is modified, every index on the file must be updated. So if index file is modified, then every file in the index file must be modified or updated. So sequential scan using primary index is efficient. Sequential scan using primary index is efficient, but a sequential scan using secondary index is expensive. So sequential scan using primary index is efficient, but a sequential scan using secondary index is expensive. So each record access may fetch a new block from disk. So each record access may fetch a new block from disk. The block fetch requires about 5 to 10 milliseconds. So each and every block fetch requires about 5 to 10 milliseconds versus about 100 nanoseconds for memory access also. So 5 to 10 milliseconds for fetching as well as 100 nanoseconds for memory accessing. So it takes somewhat time. So each record access may fetch new block from disk takes this much of time. Multi-level index. So if primary index does not fit into main memory, then access becomes expensive. So to that, the solution is what? We need to create multi-level index. So treat primary index kept on disk as a sequential file and construct a sparse index on it. So construct a sparse index on it. So that in that one is what? Outer index, and the second one is what? Inner index. So outer index is nothing but what? Sparse index of primary index. So sparse index of primary index is called as what? Outer index. So creating this outer and inner index is nothing but what? Multi-level index. So inner index is nothing but what? The primary index files. Inner index is nothing but what? The primary index file. So if even outer index is too large to fit in the main memory, yet another level of index can be created. So similarly, the levels of indexes are created because of they are not fit in the main memory. So that is what we mentioned here. If even outer index is too large to fit in main memory, at another level of index can be created, and so on. So indexes at all levels must be updated on insertion or deletion from the file. So indexes at all levels must be updated on insertion or deletion from the file. Deletion from the file. So because of that size, we need to create multi-level indexes. Multi-level indexes. So here we are creating multi-level indexes. So this is nothing but what? Outer index, and this is nothing but what? Inner index. So these are all nothing but what? Data blocks. These are all nothing but what? Data blocks. So here outer index contains parts indexes, which contains what? Index block 0. This is nothing but inner index. So which contain inner index, and the inner index contains what? Data blocks. Inner index contains what? Data blocks. So if managing these all is very expensive, but reducing the time and reducing the space is very efficient. Reducing the time and reducing the space is very efficient. So this is what? Outer index, this is what? Inner index, and this is what? Data block. Data block which contains records. Data block which contains all the records. So this is what? From index block 1, index block 0, and this is what? Index block 1. And from this index blocks, this is what? Data block 0, and this is what? Data block 1. Like that, we can create a number of levels of index. We can create the number of levels of index. So that is why it is called as what? Multi-level index. In this, this is B plus tree also one mechanism, such type of to introduce that indexing mechanism. So it is B plus tree is nothing but what? It is a router tree. It is satisfying these following properties. So what are the properties? So all paths from root to leaf are of the same length. All paths from root to leaf are same length. And each node that is not a root or leaf has between n by 2 and n children. N by 2 and n children. A leaf node has between n minus 1 by 2 and n minus 1 values. And in the special cases, if the root is not a leaf, it has at least 2 children. It has at least 2 children. If the root is leaf, that is, there are no other nodes in the tree, it can have between 0 and n minus 1 values. It can have between 0 and n minus 1 values. B plus tree node structure. So how it follows the structure actually. So every structure follows what? The search key and pointer. Search key and pointer. The same way here, the typical node, the P1, K1, P2, K2 up to Pn minus 1, Kn minus 1 up to Pn. So here Ki, that is nothing but K1, K2 up to Kn minus 1 are what? Search key values. Are all what? Search key values. And Pi, that is nothing but P1, P2 up to Pn are all pointers to the children. Pointers to children for non-leaf nodes, or else pointers to the records or buckets of records. Buckets of records. The search keys in a node are ordered as what? Like K1 less than, K2 less than, K1 less than, K2 less than, K3 less than up to Kn minus 1. In this way the search keys are in node ordered. So initially assume no duplicates and address duplicates later. Addresses are duplicates later. So what is meant by bucket? A bucket is a unit of storage. A bucket is nothing but what? Unit of storage containing one or more records. So a bucket is typically nothing but disk block. In a hash file organization, we obtain the bucket of record directly from its search key value using hash function. So search key value associated with the hash function, and it displays the bucket of records directly from search key values. So it is a hash file organization. So hash function h is a function from the set of all search key values k to the set of all buckets addresses b. So from this what? Search key values k to set of all bucket addresses b, there is a function called h hash function. So h of k to b. A comma B. So E is nothing but what? Hash function. And it is used to locate records for access, insertion as well as deletion. So it is used to locate the records, that is nothing but find out the records for accessing, comma, insertion as well as deletion process. And records with the different search key values. Records with the different search key values may be mapped to the same bucket. So records with the different search key values may be mapped to the same bucket. Thus, entire bucket has to be searched sequentially to locate a record. So records with the different search key values may be mapped to the same bucket, but in the entire bucket, it has to search sequentially to locate a record. It has to search sequentially to locate a record. So locate a record. So hash functions. Burst hash functions maps all search key values to the same bucket. So in the previous slide we said that what? All the search key values are mapped to the same bucket. Then the case is what? We need to assign each and every hash function value, search key values to the different buckets. So here the access time is proportional to the number of search key values in the file. So the access time is proportional to the number of search key values in the file. If more than one search key values in the file, then it takes less amount of time to find the records. So an ideal hash function is uniform. An ideal hash function is uniform. That is, each bucket is assigned the same number of search key values from the set of all possible values. And ideal hash function is random. So each bucket will have the same number of records assigned to it irrespective of the actual distribution. Irrespective of the actual distribution of search keys values in the file. And typical hash functions perform computation on the internal binary representation of the search key. For example, for a string search key, the binary representation of all the characters in the string could be added in the sum modulo the number of buckets could be returned. So handling bucket overflows. So bucket overflow can occur because of insufficient buckets and skew in distribution of records also. And this can occur due to some reasons. Two reasons. One is what? Multiple records have same search key values. And the chosen hash function produces non-uniform distribution of key values. Chosen hash function produces non-uniform distribution of key values. So the key values has to be distributed non-uniformly. Although the probability of a bucket overflow can be reduced and it cannot be eliminated, and it is handled by using overflow buckets. So we need to create more number of buckets for search key values. If you are not creating more number of buckets, means the bucket gets overflow, and the search keys are never find the records. Also. Hash indices. So hashing can be used not only for file organization. So hashing cannot be used only for file organization, but also for indexed structure creation. So to create the indexed structure also we can use the hashes. Hash. So but also for using for index structure creation. So a hash index organizes the search keys with their associated record pointers into hash file structure. So hash index organizes the search keys also as well as their associated record pointers. So hash index contains what? The search keys as well as associated with the record pointers also. So record pointers also. These two are into file structure, hash file structure. So strictly speaking, hash indices are always secondary indices. So hash indexes are always secondary indexes. Because if the file itself is organized using hashing, a separate primary hash index on it using the same search key is unnecessary. That means hash indexes are usually secondary indices because if any file is organized using hash function, the separate primary hash index on it using the same search key, so that it is unnecessary. However, we use the term hash index to refer to both secondary index structures and hash organized files. So we use the term hash index to refer to both secondary index structures and hash organized files also. So from these bitmap indices, so bitmap indexes are nothing but what? They are a special type of index designed for efficient querying on multiple keys. So it is a special type of index that is designed for efficient querying on multiple keys. Records in a relation are assumed to be numbered sequentially from say 0. Given a number n, must be easy to retrieve record n. Particularly, it is easy if records are in fixed size. It is easy in records of size. It is easy if records are fixed size. So applicable on attributes that takes on a relatively small number of distinct values. So applicable on attributes that takes on relatively small number of distinct values. Example, gender, country, state, these are all nothing but what? Bitmap indices. Multiple values. So example, income level is one type of search keyword. So that is levels such as 0 to 1 that we can take into different types of levels. So bitmap is nothing but what? Simply an array of bits. It is nothing but what? Simply an array of bits. And query processing. To do this all, query processing is important. So query processing is nothing but what? The activity performed in extracting the data from database. In query processing, it takes various steps for fetching the data from the database. So these steps are involved in what? Parsing and translation is one type. Second one is optimization, and third one is evaluation. So parsing and translation. So the given user queries get translated in high-level database languages such as SQL. So all the queries get translated. From higher level to lower level. So when a user executes any query for generating the internal from the query, the parser in the system checks the syntax of the query and verifies the name of the relation in the database, the tuples, and finally it requires attribute value. The parser creates a tree of the query. Known as what? Parse tree. Further translate it into the form of relational algebra. With this, it evenly replaces all the uses of views when used in the query. Thus, we can understand the working of query processing in the below described diagram. So here, how we are going to process the query. So this is the query which you are applied. So after giving the query, that should be taken by the parser and translator. So here it checks each and every syntax, each and every attribute, each and every table from the query, and that query is converted into relational algebraic expression. So that will be high level is converted into low level query. So with the help of relational algebra expression, and optimize that query. So execute plan. So validate that query. Query evaluation engine will takes place. So after executing the query output will be displayed here. So this is all the steps that are processed to performing the query processing. So this is all about the definitions and terminologies of indexing and hashing and query processing. So once again we revise the topic which we discussed in this session. So here the first one is what is meant by indexing and hashing. So types of indexes. So here the types of indexes, what are the metrics that we are going to discuss here. So indexing mechanisms, so what it contains actually, search key it contains and the index file contains. So what actually contains, it contains, the index contains what, both search key comma pointer, those two it is having. So the search key searches for all the records and pointer pointed to the next record of the file, pointer pointed to the next record of the file. So there are two types of indexes are there. One is ordered indexes and the second one is hash indexes. So ordered indexes are nothing but what, search keys are stored in sorted order. So search keys are stored in ordered. So it is nothing but what, ordered indexes. And hash indexes are nothing but what, search keys are uniformly distributed across buckets, across all the buckets using hash function. So that is nothing but what, hash indexes. And what metrics based we are going to use this indexing mechanism. So to reduce the access time, to reduce the insertion time, to reduce the deletion time, to reduce the space overhead taken by the index. So to do this all, we are going to to do that indexing mechanism, we are going to use this as a matrix. Ordered indices. So ordered index is nothing but what, the search keys are sorted in ordered way. Search keys are stored in sorted way is called as what, ordered primary index. The secondary index whose search key specifies an order different from the sequential order is nothing but what, secondary index is also called as what, non-clustered index. So here the primary indexes and the secondary indexes, sequential scans can be used, and multi-level index. So primary index does not fit to the main memory, then it access becomes an expensive. So at that moment we can go for the multi-level index. So creating an outer index, creating an inner index to find out the records. So here outer index is there. So creating outer index, creating inner index for the accessing of the records from the data blocks is called as what, multi-level index. And B plus trees also. So B plus tree is nothing but what, it is a rooted tree which satisfying the conditions which are having the same number of length of the nodes, which is node between n by 2, n minus 1 by 2 and n minus 1 values. So certain rules, based on that rule, so we can say that B plus trees. And here the B plus tree node structure, B plus tree node structure which is having both pointer as well as search key, which is having both pointer as well as search key. So K indicates what, search key values, and P indicates what, pointers. So that is, the search keys are ordered in the following way. So sorted order. So bucket is nothing but a unit of storage which contain one or more records. So it is typically it is called as what, disk block. So hash file organization. So bucket of records directly from its search key values. So all these will be using hash function. So hash functions are uniform and random. Both hash functions are uniform and random. So uniform is nothing but what, assigning the same number of search key values in the buckets is called as uniform, and assigning different number of values with the buckets is called as random. So how to handle the bucket workflow? So creating more number of search keys for the number of buckets is handling the way we can handle the different types of buckets. The hash indexes. So hash indexes, secondary indexes, primary indexes are all organize the search keys with their associated record pointers into the hash file architecture. So bitmap indices. So bitmap is nothing but what, is simply an array of bits. So these are a special type of index which is designed for efficient querying on multiple keys. And query processing. So query processing is nothing but what, it is actively performed in extracting the data from database. So in query processing, it takes some step-by-step process. What is the processes? One is parsing and translation. Second one is optimization. Third one is evaluation. So in the parsing and translation, the queries checked by the parser by all the syntaxes, semantics, tables, and all are existed or not. It checks and verified. So here the process of process of query evaluation. So take the query and convert into different tokens. So parsing them and translating them into the low level query relational algebraic expression. Then it is optimized with query evaluation engine. So the plan is executed and the query is evaluated. After then, the if query is evaluated, then it displays the output, displays the result as a query output. So these are all the different types of definitions and terminologies on indexes, primary indexes, secondary indexes, hashing, query processing, bitmap indices, and all. So these are all about the indexing and hashing definitions and terminologies. Thank you. Thank you all.
Like, share and subscribe. Hit the bell icon for more updates.